So here we're looking at questions that involve using the trigonometric ratios. So you've probably heard or seen of the three main trigonometric ratios we use are sine. So we have sine, cos, and tan. Right. So these trigonometric ratios, what they do is um, they're sort of an extension of the Pythagoras theorem. So they're not related. But if you recall, if you want to find um, the length of a side, right, and we have two sides already. So for example, in this triangle, if we wanted to find the side of this length, the length of the side, sorry, we would need to use Pythagoras theorem, right? So 12 squared plus this squared plus AC squared would give us 13 squared, and then you would be able to use that and rearrange the formula to find the length of this side. However, sometimes we're not always needing to find the length. Sometimes we also need to find the angle of a triangle. Or even if we want to find the length, sometimes we're not given two sides. We might be given one length and one angle. So when we're given that sort of information, when we don't have the two sides, or when we're trying to find an angle, that's when these ratios really come in handy, and we can use these to find out more information about a right angle triangle. So in this case, if we look at this question, it's asking us to find or calculate the size of angle BAC. Now remember, the easy way to figure out when we're given these three letters is we look at the middle letter, right? The middle letter is A, so that means that the angle we're looking at is the one next to A here. So this is the angle that we're looking at. Okay, so what I'm going to do is just to make sure we're not confused, I'm just going to rub this one out because we don't need that one. So yeah, this is the angle that we're looking at. So I'm just going to call that angle theta, right? Theta is just the symbol we usually use to denote an unknown angle that we're trying to find. Okay, and it just looks like a zero with a sort of curvy line inside it. So now using that, now what we're given is we're given BC is equal to 12, and we're given AB is equal to 13, right? Now, we can't use Pythagoras, right? Pythagoras, it only helps us to find the length of a side. So what we need to find, or what we need to use, is one of these trig ratios. Now we look at the information that we're given. We want to find out what this angle is, and we use that by using this information here on this length. So what information do we have? We have the length that is opposite this angle, and we have the length of the hypotenuse. Okay? So if we recall, these trigonometric ratios, they all are used when we have different sort of lengths. So in a triangle, we always have a side that is opposite the angle. We have a side that is adjacent to the angle. And we always have a side that is the hypotenuse, right? This is unanimous. This is the same across all right angle triangles. You will always have a side that is opposite the right angle opposite the angle. You have a side that is next to the angle or adjacent to the angle, and you will have a side that is the hypotenuse. So in this case, we have the side that is opposite, and we have the side that is the hypotenuse. Now, when you have opposite and hypotenuse, that is when we use the sine ratio, okay? So sine is O over H, or opposite of a hypotenuse. Cos is A over H, or adjacent of a hypotenuse. And tan is opposite over adjacent, or O over A, okay? So depending on what sides you have, you will use one of these three ratios. Okay, in this instance, we have the opposite side and we have the hypotenuse. So we're going to be using the sine ratio. And how do we figure this out? We do sine of the angle, or sine theta, is equal to 12 over 13, right? Because 12 is opposite. 12 is opposite, and 13 is hypotenuse. It's the opposite of a hypotenuse. Now, if we want to find the angle by itself, what we do is we take the inverse of sine. So that's just a calculator operation. You do the inverse of sine, and then the fraction that you have, and then you just put that in your calculator, and you'll get 67 degrees and 23 minutes to the nearest minute. Okay, so that's the size of this angle here. Okay, next question. Now in this question, again, we're going to be using the trig ratios, but we're finding the length of a side. So finding the length of the side RT. Now, this is what I was explaining earlier, is that even though we're finding the length of the side, we can't use Pythagoras theorem here because we don't have enough information. If we want to use Pythagoras theorem, we need to know what the other two sides of the triangle are. which in this case we do not know. So we have to use the trigonometric ratios. Now what we can see is that we have this angle here, so we can use this information. So if we look in reference to this angle, this side of 14, this is opposite that angle, and this side that we need to find, that is adjacent to the angle. Okay, we don't know what the hypotenuse is. Hypotenuse is unknown. So when we have the opposite side and the adjacent side, we use the tan ratio. Okay, because tan is opposite over adjacent, right? So we know the angle inside, so we know that tan 53 is equal to the opposite side, which is 14, over the unknown side, which is RT. And then what we can do is we can rearrange this formula to figure out what RT is going to be. So if you multiply both sides by this fraction, by this RT here, to get rid of the fraction, we get RT times tan 53 is equal to 14. And therefore, RT is just equal to 14 over tan 53. Again, that's just a calculator operation, which if you put in, you will get 10.55 centimeters to the nearest two decimal places. Okay, we're going to sort of combine that information, and we're going to do this last question. We did a similar question in our Pythagoras theorem video. So if you haven't seen that video, check that one out, and then you can come back to this one. We're basically going to be doing the same thing. It's just a multiple step process. So basically what we need to do is we need to find the value x, but we don't have enough information for that directly, right? What we'll need to find first is we first need to find this side, okay? Which I'm going to call y. Okay, so I'm going to call that side y. And we can find y because, again, we know that we have given the angle here. So we know we have the opposite side, and we have this adjacent side already. Okay, again, the hypotenuse is of no use to us. So again, using opposite and adjacent, we know that the ratio we have to use is the tan ratio. So we know that tan 50 is equal to the opposite side, which is y, over the adjacent side, which is 5. So that means that y is equal to 5 times tan 50. Okay, just multiplying both sides by 5. So I'm just going to highlight that one. Just give me a second. Yep. So y is equal to 5 times tan 50. Now, I'm just going to leave that as an exact ratio because we're going to be doing some more calculation. And I don't want to make the mistake of rounding my answer too early because then my final answer might be a little bit off. And that is a common mistake. And students do, they'll do all the calculation, right? But they'll just make the mistake of rounding this answer. They'll put this in the calculator right away. And they'll just put in their answer to two decimal places. And then when they do the rest of the calculation, the answer is going to be the answer that they'll get instead of this 4.66, they'll get 4.72 or something like that, which will be marked as incorrect. So yeah, we want to make sure that we're leaving our answers in the exact form until we get to our final answer, which is solving for x here. So now again, we have this angle here, 38, and we want to find this opposite side, and we know this adjacent side. So again, we're going to be using the tan formula. So tan 38 is equal to the opposite side, which is x, over the adjacent side, which is 5 times tan 50. So that means that x is equal to tan 38 times 5 times tan 50, which gives us our 4.66 centimeters. So this is a multiple step process, but this again is just a bit of a extension of the Pythagoras theorem. Depending on what information you have and what you need to find, you just need to figure out whether you can use Pythagoras theorem. If you can, then you obviously use that first. If not, then we go for these trig ratios to find the lengths of unknown sides or unknown angles as well.